Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an associate professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering. Today, in this session, we are going to discuss about Class D and Class E choppers. In the previous class, we have already discussed the different types of choppers, which are Class A, Class B, Class C choppers. Okay. Now, in this session, we are going to discuss about Class D and Class E chopper. So first we will discuss about Class D chopper. Here, this is the basic structure of the Class D chopper. It consisting of two chopper switches and two diodes, and in between these two there is a load that we have connected. And this Class D chopper, like the Class C, here the Class D chopper is also a two quadrant chopper, and those are we can call it as the first and the fourth quadrant chopper. It will operate in the first and fourth quadrant. And because in the first quadrant both the voltage and currents are positive, and in the fourth quadrant the voltage is negative and the current is positive. So which means by using this Class D chopper we can operate the chopper either in the first quadrant or in the fourth quadrant according to our requirement. Then how the operation of this chopper, which is Class D chopper. Then here in the first case or in the mode 1, the chopper switch CH1 and CH2 will trigger simultaneously. Then the output voltage that you will get as positive voltage and the output current also flowing through the load. Which means suppose here CH1 and CH2 are turned on or triggered, then the load current will flow from here to through CH1 through the load to CH2 to the source again. So which means here the flow of load current, here it is, the direction of the current is like this, which means let me consider this is point A and point B. The direction of the current is from point A to point B, from A to B direction. And when coming to the flow is, let me consider here plus and minus. So here V plus to CH1 to RLE, which is load, here RLE load that we have considered, to CH2 to again V minus. So during this time the voltage terminal across the load is plus and minus. Okay, so which means during this time the inductor will get charged and the inductor will store the energy with the polarities of plus and minus. So that's why the output voltage across this load V0 is also having the polarities like plus and minus. And the direction of the current is from A to B. So let me consider the direction of the current from A to B is the positive or the reference current direction. Okay, so that's why when the CH1 and CH2 is operated, then you will get both the current and voltages are positive. Both the current and voltages are positive. Next, in the next case, when CH1 and CH2 are turned off, then the load current will flow continue in the same direction through D1 and D2, but the load voltage, which means the voltage across the load terminal, will get reversed, because here when CH1 and CH2 are turned off, okay, when CH1 and CH2 are turned off, then this inductor will change the polarities and it start discharging through D2 and D1. Through D2 and D1. So that's why here, as we can see, then here the polarities I mean, initially while charging the polarities are plus and minus, then while discharging here, the polarities will change here plus and minus like this. Then it will start discharge through diode D2 to the voltage source to D1 to like this. Then which means here still the load current is from A to B only. But the voltage polarities across the load are reversed than when compared to the CH1 and CH2 are operating. So that's why here when the diode D1 or D2 are operated, or when the CH1 and CH2 are turned off, then the energy stored in the inductor will get discharged through diode D1 and D2. So because of the discharging of diode, the energy stored in the inductor through D1 and D2, the polarities, the output voltage polarities across the load will get changed. So that's why here you will get the negative output voltage, but still the current direction or the load current direction is same with the our reference direction, which is A to B. So which means in this mode of operation, the voltage is negative, but the current is still positive. So which means this is the fourth quadrant operation. This is the fourth quadrant operation. And in the previous case, both voltage and current are positive. So in the first quadrant, both voltage and current are positive. So that's why this is the first quadrant operation. So this is the operating principle of the class D chopper. But the quadrant operation, okay, is not depends on, because in the previously, in the class A, class B and class C, let me consider class C chopper. In the class C chopper, of course, the class C chopper also having the two chopper switches. So like it will also, the type C chopper also called as a two quadrant chopper. And if you want to operate in one quadrant, then you have to operate that particular chopper switch. And if you want to operate in another quadrant, then you have to operate in this other particular chopper switch. But here it is not like that. Okay, the two chopper switches are we are operating at a time, and we are turning on at a time, and we are turning off at a time. Then how we can shift from one quadrant to another quadrant, from first to second or second to first quadrant? That is depends on the duty ratio. Okay, the duty ratio, or we can also, that is depends on the turn on time of the chopper. The turn on time of the chopper switches. First, let us consider T on is greater than T off. Anyway, here the current is continuous only because of the inductor. Okay, so that's why here the current is always continuous. So the output current waveform is more or less it is continuous only. But when coming to the output voltage, here as you can see, in the first case T on is greater than T off, which means here this is the T on period and this is the T off period. Then if you take the average value of this voltage waveform, then the average value of the voltage waveform is always positive, because here the T on is greater than T off, and the current is always positive anyway. So then the current is also positive. So which means this is the first quadrant operation. This is the first quadrant operation. And in the second case, suppose if you want to operate in the second quadrant, then you have to take the T on value, which is T on is less than T off. In this case, as you can see here, this is T on again, okay, and this is T off again. Because as you can see here, CH1 and CH2 are turned on during this period, and during this period, CH1, CH2 are turned off. That's why here D1, D2 starts conducting. So this is T on and T off. Then if you take the average value of this output voltage waveform, then which is always negative, because here the T on period is less than the T off. So that's why here the average voltage value is negative. So which means here V0 is negative, but still the current is positive. So I0 is equal to positive. So which means this is in the fourth quadrant. So this is how we can shift from one quadrant to another quadrant by changing the duty ratio or by changing the T on time. Because again, what is the duty ratio is T on by T. Okay, if T on will change, then duty ratio will change. Because let us consider if the T is constant, then duty ratio is proportional to T on. If T on is greater than T off, okay, then it will be operate in the first quadrant, and if the T on is less than T off, then it will be operate in the second quadrant. Like that, we can shift from one quadrant to another quadrant. This is about the class D chopper. Next, we are going to discuss about class E chopper. So till now we have discussed single quadrant choppers, which are class A and class B, and two quadrant choppers, which are class C and class D. Then another one is the 4 quadrant chopper, which is class E chopper. Which means by using this single chopper, okay, by using this single circuit, we can operate in 4 different quadrants. You can operate in the 4 different quadrants. So that is one of the main advantage of this class E chopper, which means the power can flow from source to load. That is the common thing. But by using this chopper, it is also possible from load to source. Not only from the source to load, it is also possible from load to source by using this class E chopper. Then the same class E chopper, okay, how you can operate in the first quadrant or the second or the third and fourth quadrant. Because here, as you can see here, this is the 4 quadrant choppers. Here, one thing that we can observe, in the single quadrant choppers, those are having only single switches or single chopper switches. And in the 2 quadrant choppers, like class C and class D, they are having 2 switches and 2 diodes. And this is the 4 quadrant chopper. It is having, as you can see, 4 switches, namely 1, 2, 3, 4, 4 switches and 4 diodes. So here, suppose if you want to operate in the first quadrant, then you need to operate switch 1. The operation means turn on and turn off. We have to do both the functions. And similarly, if you want to operate in the second quadrant, then again you have to operate switch 2, on and off. And third quadrant, then switch 3, on and off. You can see here, CH1 is operated in the first quadrant, and for the second quadrant CH2 is operated, and the third quadrant CH3 is operated, and the fourth quadrant CH4 is operated. Operation is nothing but here initially here CH1 is turn on. Of course, in addition some other switches also we are turning on, but the operation is nothing but the full operation is on and off. So we are doing on here and again here off. Similarly, in the second case, second quadrant also CH2 is turn on and CH2 is turn off. Similarly, CH3 is turn on and CH3 is turn off. Similarly, CH4 turn on and CH4 turn off. Like this, we are by operating the switches, okay, we are operating the chopper in different quadrants. That is the beauty of this class E chopper. Then we will discuss one by one. First, the first quadrant. In the first quadrant, initially, let us consider, like in this case, all the switches are in the turn off position. Okay. Then now we are going to operate the chopper in the first quadrant. And as we discussed, if you want to operate the chopper in the first quadrant, then you need to operate the chopper switch 1. Okay. So here in the first quadrant, we are operating chopper switch 1. So with addition to the chopper switch 1 here, we are also turning on the chopper switch 4, S4. Okay. So initially we are turning on S1 and S4. So in the first quadrant, what should we get? Both voltage positive and the current also should be positive. So we will see. First CH1 and CH4 are turned on. Then here the blue lines indicates the direction of the load current. So from here to here. Then here, of course, in this case, the back EMF directions is plus and minus. Okay. So let us consider the load is RLE, and in this case, maybe the inductor stores the energy. Okay. Then here, the terminals of the load voltage are plus and minus, and the direction of the current is, let me consider again here some A and B. Okay, from A to B. So let me consider this is the reference current direction, which means the positive current direction. So when CH1 and CH4 are operating, the voltage across the load is positive, and the voltage across the, or the current flowing through the load is also the positive direction. So that's why this is in the first quadrant operation. And next, because we are saying like switch one is operating on and off. In the next case, okay, initially we have turned on, then we are turning off the switch. When we are turning off the switch, because during the turn on, the inductor will store the energy with the polarities of plus and minus, okay, and in this case it will change the polarities and it will discharge through again in the same direction, which is the inductor will discharge in the same direction, which is from L to this CH4 to D to this RA. Of course, here we may get doubt why the D2 should turn on, because of course here we should provide some discharging path to this. Okay, so here it will not go through this D2, D3, because already here the switch S1 is turned on, so it will go here. Okay, it will enter and then it will leave. Here S2 is turned off again, so that's why it will go through the D2, and this is the direction. So which means again here the current is positive only, and the voltage is also here. You can see the back EMF plus and minus, same like in the previous case. So that's why when the chopper switch is operated, then you will get the first quadrant operation, which means here let me consider this is the let me see here voltage or current, what we have considered. Yeah, voltage, this is V0 and this is I0. Okay, so here V0 is positive and I0 is positive, then which means this is the first quadrant operation. Then coming to the second quadrant. In the second quadrant operation, we have to operate switch 2, that is S2. So initially the S2 was turned off position, so that now we are operating, so which means just turning on the switch S2, okay, then this back EMF, as you can see here plus and minus, okay. Then when the turning on the switch S2, because during the switch 1 is operating, the back EMF will produce, okay, and when turn on the switch S2, here then the back EMF will act as ES will act as a source, then it will act as a source. So before it was plus and minus, okay, here also plus and minus, then here it will go through like this. It will discharge, or the load current will flow through like this, which means from this way. So the current direction is different. This is the second quadrant, but still the output voltage polarities are same, plus and minus, because we are considering here the ES is EB, the back EMF is the source, so the source polarities are plus and minus. So that's why here the output voltage polarity is also plus and minus, but the current direction is from here, because we have considered this is AB, this is from B to A, so the opposite to our reference direction. So that's why here the negative current. So which means again here this is V0 and this is I0. Okay, this is minus I0 and this is plus I0. So V0 is positive but I0 is negative. So which means this is the second quadrant operation. Then now we are turning off switch S2. Okay, and again here also during turn on S2, the inductor will charge with these polarities. Then when turn off S2, the inductor will get discharged. Then here during switch S2 is turned on, the inductor will get charged with these polarities plus and minus, and when the switch S2 is turned off, again we need to provide the path to discharge this inductor. Then when switch S2 is turned off, then here the inductor will discharge through like this. So which means here the load will supply energy to the source. The load is supplying energy to the source. So again here the direction is opposite, but still the the polarities are same. So which means this is the second quadrant operation. Then coming to the third quadrant operation, in the third quadrant switch 3 is operated. So initially the switch 3 is in the turn off position, then now we are turning on the switch 3. So with addition switch 3, switch 2 also we are turning on, which means here the switch 3 and S3 and S2 are turning on. So here then the load voltage or load current will flow from here to this S3 to this way to this way. Which means here then because here the current is entering from here, so that's why here the back EMF polarities has been changed minus and plus or plus and minus. Okay, and the load current direction is also from B to A, so which means opposite. So which means here both the output voltage and the output current polarities are different than with respect to our reference output voltage and current direction. So that's why both output voltage and current are negative. Both output voltage and current are negative. So which is here this is I naught and this is V naught and this is minus V naught. Okay, and this is minus I naught. So here this is we are considering as a first quadrant, and here it is second, and here it is third, and here it is fourth. Okay, so in this case when switch 3 is operating, we are getting both current and voltages are negative. So that's why this is in the third quadrant operation. Then during this time again this inductor will get charged with these polarities plus and minus, because the direction of the current is from B to A. Then again we have to provide the path to discharge this inductor. Okay, so of course anyway here in the third quadrant initially we are turning on the switch S3. Now we are going to turn off switch S3. Then if you turn off switch S3 but still S2 is turned on position, then the inductor polarities will change during the discharging, like this plus and minus. Then again it will start discharge through S2 to this D4. S2 to D4. So here already the voltage polarities are reversed, and again the current is also reversed. So that's why this is the third quadrant operation. So both voltage and current are a reverse direction with our reference voltage current direction. Then coming to the the fourth quadrant. In the fourth quadrant, the switch 4 should be operated. So initially again the switch 4 is turn off position. Now we are turning on the switch 4. Okay. So when turn on the switch 4, again here the back EMF will act as a source. Okay. Then here it will supply through S4 to this D2 like this. Which means the current is positive only from A to B. But the voltage is reverse. So the current is positive and voltage is reverse is in the fourth quadrant. That's why it is in the fourth quadrant operation. Then if you turn off S4, then because when turning on the S4, here the inductor stores the energy. Because here the supply is this way, so plus and minus. Okay. Then now here it is plus and minus. Then it will discharge through D2 to the supply to D4 D3 to D2. So in this case also the load is supplying to the source. So this is the fourth quadrant operation. This is the operation of the class E chopper. Very simple, right? Because if you consider here this y-axis is the voltage and x-axis is the current, and if you consider this is the first quadrant and second quadrant and third and fourth quadrant, if you name it like this, then the switches, okay, and the numbering is like S1, S2, S3, S4. Then if you want to operate the chopper in the first quadrant, then you need to operate S1, which means operate means on and off. And in the second quadrant, S2 on and off. In the third quadrant, S3 on and off. In the fourth quadrant, S4 on and off. So by operating the different switches, we are getting the different quadrant operation. This is according to our requirement. The best application for this class E chopper is lift or hoist. lift or hoist. One is the cabin, another one is the counterweight. So because there are four possibilities that you will get, and the four possibilities, okay, which means the same lift, okay. Let us consider in one case, of course, there are only two, I mean, initially there are only two cases. One is it's going to up, and one is it's coming down. But when going, I mean, while going up, it may be full cabin or empty cabin. Similarly, while coming down, it may be with full or empty. So four cases: 1, 2, 3, 4. In these four cases, you need to supply in four different ways. In this case, we use the 4-quadrant chopper. This we will get understand clearly. I mean, when we are going to discuss about the chopper fed DC motor, we can understand. Okay, so like what is that motoring operation and braking operation. Okay, and again in the motoring, forward motoring and reverse motoring, and again in the braking, forward braking and reverse braking. So the four possibilities here you need to apply to function this hoist or the lift. So in that case, we use this class E chopper. This is the best chopper, or this is the best converter suitable to operate this hoist with DC motor. This is about the class E chopper. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.